For this video, we're going to go through section 8.6, solving rational equations. It's not that lengthy of a section, but the problems are more complicated. So what I do on the screen, you're going to want to write it down, take good notes, stop, rewind, do what you have to do, and then you really might want to go back and try some problems on your own before class, just to see if you got it. Okay, so after this lesson, you should be able to say, I can solve rational equations. For our first example, we're going to use a technique that you guys have seen before, solving a rational equation by cross multiplication. Okay, if you guys remember, cross multiplying means when you have two ratios or two fractions, one on each side of an equal sign, you're going to multiply across. Okay, so our first move is to go 3 times 4x plus 5. Then we're going to put our equals sign down, and we're going to set that equal to the other one multiplied across. 9x plus 1. And again, you can, when you have two ratios or two fractions, one on each side of an equal sign, you're going to multiply across. Okay, so our first move is to go 3 times 4x plus 5. Then we're going to put our equals sign down, and we're going to set that equal to the other one multiplied across. 9x plus 1. And again, you can do this anytime you have two fractions equal to one another. Okay, now we're going to use our algebra solving techniques. I distribute. I combine like terms. Okay, now we have a one-step equation here. We're going to go ahead and subtract 15 from each side. We get 3x equals negative 6. I divide by 3. And I'm left with x equals negative 2. That means that if you plug negative 2 into that equation, you should get them to equal one another. Another technique that we need to talk about is solving rational expressions by multiplying by the least common denominator. Okay, so we have the equation 5 divided by x plus 7 over 4 equals negative 9 over x. When I solve equations, any type of equation, we always need to make sure we're balanced. Whatever you do to one side, you have to do to the other. For this one, we're going to look at our denominators. Okay, I have a 4 and an x. I want to multiply both sides by the least common denominator to get rid of those fractions because we don't like them, they make life difficult. So the least common denominator, to figure that out, I'm going to take both denominators, 4 and x, and multiply them together. I get 4x. That is my least common denominator. I'm going to do the same to this side. This side just has an x, but we already took that into account over here. Okay, if this was different, I would have to multiply it in there too. But it's not. It's the same as that. So we're good. Our least common denominator is all of your different denominators multiplied together. Just don't forget to multiply the other side too. Otherwise your equation will be off balance. Okay, so we have a number on the outside of an expression. We're going to have to distribute. 4x times 5 over x gives me 20x over x. Again, those x's are going to cancel, so we're left with just 20. Then I'm going to go 4x times 7/4. That leaves me with 28x over 4. Remember, with fractions, when you multiply a fraction by a whole number, you're multiplying across. And it's just like it's over 1. 28 divided by 4 is 7, so it's going to reduce to 7x equals Now on the other side, again, I'm going to multiply a whole number by a fraction. I multiply straight across. We get negative 36x over x. The x's cancel. That leaves me with negative 36. We're going to go ahead and solve with our algebra techniques here. We subtract 20. That leaves me with 7x equals negative 56. I'm going to divide both sides by 7. I'm left with x equals negative 8, which is b. So just to summarize this one, we started off by multiplying by the least common denominator. I took all of the different denominators and multiplied them together. Then you just need to make sure you're doing proper algebra technique. If you have a number outside, you distribute. Don't forget, we multiplied that side by 4x. We have to do the same there. Okay, this would be an excellent problem to stop and try one just like it out of the homework section of 8-6 on your own, but of course we'll do more in practice tomorrow. Okay, same one here. We have 1 minus 8 over x minus 5 equals 3 over x. What I'm going to do is look at the denominators. I have an x minus 5 over here. This is a 1. Again, we just make that over 1. Here's an x minus 5. Here's an x. I take the two different denominators, multiply them together. That becomes my least common denominator. It's just like if you're trying to subtract 3/8 minus 4/5. We want to figure out the least common denominator between 8 and 5. The only way to get that is to multiply them together. It would be 40. Okay, so for this one, we're going to multiply both sides by x times x minus 5. So we're going to go x times x minus 5, and we're not going to multiply them together yet, just in case stuff cancels. And then I'm going to do the same to my other fraction here. Okay, so I have a number outside parentheses, an expression inside parentheses. Again, I have to distribute. This is going to be x times x minus 5 minus, oh, and look what's going to happen here. I'll have 8 times x minus 5, so that's going to be 8x x minus 5, and that is over another x minus 5. So what's going to happen there? Those are the same. They cancel. Okay? Equals, and then the same deal here. We multiply straight across. We're going to get 3x times x minus 5 over x. And today we kind of talked about how this stuff simplifies. We have a 3x outside of a parenthesis, so it's in good place to be simplified, and an x on the bottom. So those x's cancel out. So I'm left with x times x minus 5 minus 8x equal to 3, and I'm kind of getting scrunched here. I'm going to move it over a little bit. So we have x times x minus 5 minus 8x equal to 3x minus 5. Now we've got some simplifying to do. Take a minute, look at what we've just done. Maybe look at it again. We started with multiplying both sides by the least common denominator and then distributing across. Take a second and look at it and see if you can simplify.
Rebecca Kruger, Josh Miller, Elizabeth Buchholz, Jacob Ross, to guidance, please.